Okay, once the water lines are drilled and the mold is ready to go and it's assembled, I wanted to show you what I was talking about over by the radial drill press. But when this Jiffy Tight goes in here, there will be two of them, one on this side, one on the other side. Normally we'll mark in and out, or out and in. It really doesn't matter. You as a toolmaker know what the flow should be, so kind of nice for the operators on the molding machines to let them know which one is in and which one is an out. But in any event, what I was talking about in regard to the spacing of that, they have to be 2 to 3 diameters apart to have enough meat in here to convect as the water's coming through. But also in this case, you've got toggle clamps on some of these quick change mold sets, and when those toggle clamps are thrown on there, you have to make sure you've got enough room. So if this water line were out another 1/4 of an inch to a 1/2 inch, you could see that you wouldn't be able to get this Jiffy Tight onto that fitting, or maybe even get the fitting in there. So you have to kind of think that through as you're designing and look at the logistics of everything as your die is going together. Okay, so another thing that we wanted to talk about was, as you get your blocks ready, you'll notice here I have a 1/4 20 tapped hole. And that 1/4 20 tapped hole is for this slide hammer. This is a homemade one, and it kind of comes from the body pulling tools that auto body people use. But it's just a 1/4 inch threaded rod with a chunk of steel on the end of it and a washer and a nut. And so when you get this in there, to get it out of there, depending on how tight you fit it, and when the mold heats up and there's some, you know, coolant in there and maybe a little rust buildup, whatever, you're going to be hard pressed to get that die out of there when you're quick changing to get another job in there. So if you have a 1/4 20 hole tapped in there, all you have to do is thread this jackhammer, or slide hammer I should say, in there, and then take the toggle clamps off, and then you can take and jackhammer it out for yourself. Okay, so it's a real nifty idea. So I would recommend it on all of your mud sets, that you find an inconspicuous place that doesn't affect the die and put a threaded hole in there so that you can get the part out. Now, if you take a look at the design of this die set, we have 2 ground plates that are bolted and doweled together. And so this makes a sharp here, but it does not make a sharp here. That was cut out with a cutter and maybe a grinding wheel, and I can guarantee you that right there and right there, those corners are not necessarily dead sharp. They might have been radiused a little bit. So when you take your die block and you've got everything ground up real nice, you're going to find out that you're thinking you're fighting the width here, the 5-inch width, or the thickness of this 248 ear here, and you're going to find out you're fitting against those radii in the corners with sharps. So there's a couple of things you can do. I'm going to take you over by the milling machine here and show you before you try and fit it, and while you're grinding to fit, that you can take a 45 vise like this and set it up, and then we're actually going to cut an undercut, and we can also cut a chamfer on there to knock that sharp. Otherwise you can hit it with a file. So I've got a 45 vise set up, and this is an angular 45. It goes angled this way, it goes angled that way. So what I do is I set it up, throw an indicator in the spindle, and I'm just going to run down and I'm going to tap it around. And in this case, I'm just going to make a relief groove in there for the ear. So as long as I get it within about 1/1000th of an inch, I'm fine. So we're going to quick cram that. Close enough for Hartford. We're going to lock it down. And now, to find the middle of that groove, what I'm going to do is I'm going to take a ball end mill, and this happens to be a 3/16, and I'm going to run that ball end mill down and make a groove in here so that it's relieved, so that I don't have to fight those corners. And that also allows me to have a little gap here, so I can use the surface grinder periphery to grind this, and I can use the surface grinding periphery to grind this, so I don't have to mess around with side wheeling. So I need to find the middle of that. Now, again, This is relief, it's clearance. I wouldn't be all too concerned about it. What some people will do is they'll put a dowel in that V-notch, hold it with their finger, throw an edge finder in there, and edge find, and they found 0. Another option, believe it or not, you can actually take an indicator and you can come in there and set preload, and you can actually spin this. So I've got positive 10 and positive 5, so I should probably buy a lottery ticket today because I eyeballed it pretty close. I'm just going to move it back and forth a little bit. So just like you're tramming the outside of a block, you can do that same thing here if you want to be super accurate. Not that this has to be, but I just wanted you to realize that you can also tram in a V-notch. There we go. I'm 0, 0, so I'm going to 0 my y-axis here.
Close enough for Monroe.
Okay. And I suppose it should be pretty accurate because I think this is Drew's block. So he's going to want me to make it 0, 0. So we're going to take our indicator out. And again, I don't have air. Otherwise, I would set up one of those vegetable oilers, and that would probably help extend the life of this cut.